Hi everyone, Hina Wajid here. Now our next MCQs is beam intensity highest at option A far field, B focal zone, C near field, D edges. First try to give answer by yourself. Okay, right answer here is B focal zone. Beam intensity is highest at the focal zone, and this is also known as spatial peak intensity. Spatial intensity which varies by area or space. Spatial peak where it is maximum. So it is maximum at focal zone. Spatial peak intensity is seen at focal zone. How we can say that? Beam intensity is highest at focal zone. So we have a formula. Intensity is equal to power divided by area. So when area decreases, intensity increases. Both are inversely related. As a beam becomes narrows, smallest area, then intensity rises. Narrowest point is the focus point, focal zone point. Spatial peak intensity is also present at the focal zone. Another very important point is best lateral resolution is present at the focal zone where the beam is narrowest. Why? Because lateral resolution depends on the beam width. Where the beam is narrow, lateral resolution is highest. So intensity is highest at the focal zone. Lateral resolution is best at the focal zone. Now what controls the focus and the beam width? So there are two main factors: aperture size and frequency. So higher the frequency, longer the near field, longer the far field, but it makes the beam narrow. Aperture size, higher the aperture size, it makes near field longer, far field longer, and focal zone narrow. Overall make beam narrow, reduce the beam width. And then there are some focusing methods like electronic focusing, acoustic lenses, curve elements. So these are curve elements, acoustic lenses. These are the types of the mechanical focusing. And one is internal. Curve element is type of internal focusing. Acoustic lenses are types of external focusing. And nowadays electronic focusing is used, which further have the types like the transmit focus, dynamic receive focusing, also a dynamic aperture focusing. So these are the methods to improve the focal zone, because focal zone is a point where the intensity is highest and the lateral resolution is also highest. Now our next MCQs is if intensity halves, change in decibel: A minus 10 decibel, B minus 1 decibel, C minus 3 decibel, D minus 6 decibel. So first try to give answer by yourself. So the right answer is minus 3 decibel, and it's very important concept. So what is a decibel? Decibel is a logarithmic ratio that describes relative power or intensity change or amplitude change or voltage change, etc. So in ultrasound, like whenever the change happens, so we describe the change in the decibel. So decibel does not give us absolute value. It is a relative scale. So what is the benefit of it? It reduces the very large numbers into very simple numbers. Like here we can say, when intensity becomes half, change in decibel is minus 3 decibel. When intensity doubles, then the change is plus 3 decibel. When power or intensity double, change is plus 3 decibel, and when it become half, then change is minus 3 decibel. This is very important rule. And for amplitude, these values are double, because we know intensity or power is directly related to amplitude square. So when power double, change is plus 3. When amplitude or voltage doubles, change is plus 6. When amplitude or voltage becomes 1/2, change is minus 6 decibel. So you have to remember these rules. For power and intensity, when it doubles, change is plus 3 decibel. When it becomes half, change is minus 3 decibel. For amplitude, voltage, when it becomes double, the change is plus 6 decibel. When it becomes half, the change is minus 6 decibel. And why this happens? Because there are proper formulas for the calculations. For intensity, it's 10 log ratio. For power and intensity, this formula is used. For amplitude or voltage, this is the formula, 20 log ratio. Now what is the ratio? So ratio is final value divided initial value. For example, if intensity was 1 and then it changes to 100, so our ratio will be 100 divided by 1. So our ratio is 100. Now we have to find the log of 100. So log of 100 is equal to 2. You have to remember these simple values. Log of 10 is equal to 1. Log of 100 is 2. Log of 1000 is 3. Log of 10,000 is equal to 4. And so on. And if it is 1 by 100, 10 raised to power minus 2. Log of 1 by 100 is minus 2. Log of 1 by 1000 is minus 3. So that's how we can calculate the change. So if our ratio results in 1000, so we know log of 1000 is equal to 3. Now we have to calculate the change in the power. So we know decibel change in power is equal to 10 multiplied log ratio. Log 1000 is equal to 3. So answer will be 30 decibel. So it means whenever the ratio value is equal to 1000, answer is always plus 30 decibel for the power. So we can remember it for the power or the intensity. Whenever the ratio, which is final divided by initial value, that ratio is 100, then the change is plus 20 decibel. When it's 1000, the change is plus 30 decibel. When it's 10,000, the change is plus 40 decibel. When it's 1 by 100, change is minus 20 decibel. When it's 1 by 1000, change is minus 30 decibel. 1 by 10,000, change is minus 40 decibel, and so on. Now for the amplitude or voltage, because formula is 20 log ratio. So values are just double as compared to the power. For example, if it is log 100, so log 100 answer is 2. 20 multiplied 2, answer is 40. So when ratio is 100, amplitude change is plus 40 decibel. When it's 1000, answer is plus 60 decibel. So when intensity reduce, it becomes half, change is always minus 3 decibel. When it becomes double, then change is plus 3 decibel. When voltage or amplitude double, change is plus 6 decibel. When it becomes half, change is minus 6 decibel. So these are the decibel rules. Now if the intensity becomes 1 by 4, then how much change occurs in the decibel? So when it becomes half, change was minus 3. It again becomes half, change is again minus 3. So minus 3 and minus 3 results in minus 6 decibel change. So when intensity or power becomes 1 by 4, change is minus 6 decibel. And when I say now intensity becomes 1 by 8, like it again become half. So first it was 1 by first it become 1 by 2. So the change was minus 3. Then it become 1 by 4. Change was again minus 3. So overall when we add, result is minus 6 decibel. Now it become 1 by 8. Again it becomes half. So again we add minus 6. We add minus 3 in the minus 6. So answer will be minus 9 decibel change in the intensity. So this is how we can simplify the decibel for the exam. If your SPI exam is near, so I am there to help you. I have prepared 60 details SPI lectures covering whole ARDMS SPI content outline in a simple and easiest way possible. And I also have added MCQs in each of the topic. So you will get very easy explanation of all the topics along with the MCQs practice while discussing the topic, and along by the side you will do the MCQs practice. And I will also share all of the slides of every session for the easy review. And then I have MCQs test topic by topic. Like you listen one lecture and then you solve the MCQs of that topic. So you will evaluate your knowledge by this. And I have total 2000 plus MCQs to practice. I also have mock test, so you can review your knowledge. And the great thing is there is a one-to-one revision session before the exam, so that I can assess your knowledge and I can give you feedback what to improve. And there is exclusive bonus. I will provide you free guidance on ARDMS whole registration process. If you join our sessions, I will guide you about everything. Documentation, ARDMS supply guidance, exam booking procedure, SPI registration, A to Z, everything. So now you can enroll in our whole session. Or if you have already prepared, you just need MCQs practice, or you just want mock tests, or you just need one-to-one revision session before the exam, so you can contact me on my email for all the details.